Welcome to the Trend Detection Podcast, powered by Siemens. And now your host, Niall Sullivan.
And I guess, again, linked to that is sort of the data acquisition strategy. Are there sort of challenges or more challenges for acquiring data for vibration analysis compared to other forms of analysis? Or is it?
Well, I think that you do have to have an analyst mentality. You have to look at repeatability. You have to look at some kind of stability within an asset. We're trying to trend an asset or a machine that is doing the same thing over time, trying to compare apples to apples, if you will. So you're looking for repeatability. You're looking for operational conditions and characteristics from a machine that you can capture time and time again reliably. So that might be selecting a certain speed range from a machine that varies in operational speeds and identifying that as your test point and grabbing samples when the machine is in that condition.
And as you mentioned machines, are there typical machines or assets where this kind of analysis works better than other types of assets and machines?
Yeah, I think that in all rotating equipment, it can work. In all linear applications, it can work quite well. Traditional equipment that doesn't have a BFD controller make life easier. Pumps, compressors, fans, of course, AC and DC motors. So traditional industrial equipment, they're all candidates. I think that the applications that have taken a lot of determination to find good testing parameters for have been things like cranes, vehicles, elevators, things that have maybe brief moments of operation that stop and start and go again. Those have been the most challenging applications. And then today with high efficiency motors, variable frequency drives, motors can shift in speed and operational characteristics and ramp up and ramp down quite quickly. So those have all added new challenges and really have kept things exciting over the years to solve new problems. But there's a way to solve almost every problem out there. It's just, looking at the application and solutioning appropriately.
I guess that's exactly why you're in the role you're in, Chris, with that kind of that kind of attitude. A problem could always be solved. I like that. That's very good, especially in our world as well. But in terms of on the customer side, you talked about the different assets that maybe it could be applied to, but is there a lot of education required, when you're talking to customers about where best to apply it, or is there a lot of expertise in, let's say, vibration analysis internally in those organizations?
Yeah, I think again, you get people in with varied amounts of experience, and people can often overlook the basics. Sensor application, installing the sensor on the proper spot in the machine to get the best frequency response, using the best, mounting methodology for the sensors so that you're not dampening the signature. Sometimes even removing the paint between the sensor and the actual machine housing is critical. And so I think those types of things are important. I have seen a lot of cases where a new sensor vendor might not have field personnel or might not have partners that can help with these types of things, and they send a box of sensors out to a plant somewhere. The maintenance people open the box and they say, well, I guess we stick these on the machine. And, they may Google things a bit or try to find a good approach, and they give their best shot, and they're working with what they have. So you can't blame them. But, a little practical guidance and understanding and consulting along the way means that, you lay the groundwork for a solid program by installing the equipment correctly to begin with.
I was going to say it's probably, because I guess that causes more issues down the road if it's not installed correctly to start with. It just has a knock-on effect for future, projects involving that data, right? Like predictive maintenance, as an example.
Yeah. Today we're bringing in data sources from all over the world, and it's not a Senseye problem. I think many people are grappling with this. You've got a signal coming in; it's vibration data. maybe you have some header information about that data, but you're not physically on the site. You can't easily go and answer the first question: is this sensor installed appropriately? So, the challenge.
Yeah, yeah. Actually, I mean that's a good point because, like I said, in the world we're in now, a lot of this is done remotely. Does that cause additional challenges for installing, sensors and vibration analysis and everything on that side?
Yeah, I think there can be assumptions and gaps, right? I don't think that you have to have specially trained personnel come out and deploy all of your vibration sensors, but I do think that you should take care to make sure that if you're going to use internal personnel, that they're trained, that they have resources, that they can ask questions, um, and just be able to ensure that it's being done the right way.
Yeah, no, makes sense. Makes sense. In terms of, I guess, looking into the future a bit, is there any sort of emerging trends or advancements in technology you see in vibration analysis specifically, Chris, that's going to sort of impact, our customers and global, organizations?
Yeah. I think that this automated diagnostic capability, this screening of mass amounts of data, will help organizations to look at mass amounts of data and focus on the data that really requires further analysis. We've done some research here, and really it's kind of an 80-20 rule or even a 90-10 rule as we move along. You've got thousands of machine tests potentially coming in from a facility, and you want to zero in and focus on the 20% or 10% of data that requires further analysis. I don't think that AI does away with the human capital here, the value of the knowledge of the human analyst to make further decisions. There's always contextual situations where a decision has to be made about whether a line is going to be brought down, whether you're going to shut down a facility or a process to repair something. So I think AI brings it all through and has the potential to analyze mass amounts of data and allow the experts, specialists, maintenance planners, plant managers to be empowered to make decisions on whether to take action or not.
And do you feel that maintenance people and other people who use products like Senseye are really starting to trust the technology? I mean, obviously, we've got lots of customers using the technology, so that's true. But I mean, just in general terms, I guess, is it becoming more trusted as these kind of platforms?
I think so, and we've got to kind of do our best to maintain integrity in the industry. If organization, a company is set out with a new wireless vibration sensor, for instance, and that's their core product, and all their analytics and everything is tied to that sensor. They're going to go out in the market and sell their clients on the capability of that sensor. So often, to put things gently, things can be oversold, right? The capability of a sensor can be, touted to catch all machine faults, to be embedded with AI capability, to be your all-in-one solution that's going to solve your problems and tell you when your equipment is going to break. And I think we have to be careful selling that easy button or solutioning equipment that is not going to be appropriate, because it affects people's confidence, right? If your first exposure to predictive maintenance is you enter your plant floor, that somebody a year ago, 6 months ago, bought 100 vibration sensors. You're getting data from them, but your machines are still breaking. You're not getting any kind of prediction or forecasting. You might start to doubt the whole approach. And so I think we have to take care to solution appropriately, to look at the data and make sure that the fault indicators are present, so that we don't just say, oh yeah, you put that sensor on there, you're going to have all the prediction you want. Everything's good, right?
It's interesting because I had a conversation actually with one of our colleagues, David Peterson, yesterday, and we were talking about this this issue of trust, and being maybe not, yeah, is the right word, being burnt, I guess, by previous PDM deployments, or whether it's an internal project, whether external, but it's that feeds into this trust element. If you've already had bad experiences, for example, it can be sometimes harder to believe, what you're being told is true, for future, projects you want to pilot.
Absolutely. And I think there's just too much documented success out there. And it's unfortunate when people get brief exposure to a vibration analysis program or a predictive maintenance program that it doesn't have a solid foundation. They walk away feeling like this could be a bit of snake oil, or that the predictive maintenance world is just a bit overstated, or we're not worth it.
Yeah, I guess in a broader market sense, I guess there's so many organisations saying they do predictive maintenance. Even my time at Siemens or Senseye, we've had in 3 years there's been massive advancements. I walk around shows now and it says everyone says they're doing predictive maintenance now. Do you see that as well? In the context of what we're talking about today, vibration analysis, so maybe calling it predictive maintenance because that's the cool phrase to use at the moment. So just slap that on top of it.
Yeah, and once you dig deeper, I think people that are determined to learn and differentiate will quickly find that many solutions today are really truly condition monitoring, and that means identifying a fault that has already moved far enough along the prediction, or excuse me, the fault development scale to be identified. That means you already have a problem. It's already significant enough that you're going to need to take action, or it's already so significant that by the time you are able to take action, a failure might occur. And so predictive maintenance, right, is moving further back on that curve, further back on that scale, and predicting the very early developments, the very early indicators. A fault doesn't have to be fully developed. The preceding indicators just have to be there. And that's where you get predictive, and that's where you truly get weeks and months of time to make informed decisions about developments in your equipment.
Absolutely. No, really interesting. I guess as we're sort of coming towards the end now, and again, like I always say, the time seems to go very quickly. People who listen to this, I say this every time, but it really does, especially in a sort of 30-minute episode. But I guess before we finish today, Chris, it might be interesting for people, if you've got any advice on people looking, when we said about knowledge gaps and shortages of skills. I mean, if people want to get into this sort of industry, do you have any sort of tips on that side for anyone?
Yeah. I think as long as you have a background in rotating equipment, you have a desire to learn and solve problems, you can really get started. There are a lot of online resources. Siemens can help in that regard. If you're looking to start a predictive maintenance program or a vibration analysis program, more specifically here within your facility, you can learn on the job. That's going to be important. And then there are training organizations out there like Mobius Institute, Vibration Institute, that can help move along and get you certified, so that you can be assured you have a certain amount of knowledge to take forth. And it really goes through 4 tiers of certification. The first tier starting with just being competent on installing sensors, selecting the right sensors, as we discussed today, because that really is the critical start.
Yeah. No, absolutely. But no, that's really great. As like I said, I think we've covered everything in great detail today. If you want to discuss this further, I can put, if Chris is okay, I can put your LinkedIn details. So if people want to connect and sort of discuss further or have any questions, that'd be, if that's all right with you, Chris.
Please do.
Absolutely. So I think that's all for today. So thank you, Chris, for your time today and for sharing those insights with us. And thank you for everyone at home or at home, or wherever you are in the world for listening.
Please like and subscribe on all major podcast channels and find out more about Senseye Predictive Maintenance at Siemens.com.